Everyone, can you listen to me? Please type something on the chat if you listen to me. I'm live right now. Everyone, can you listen to me? Please type something on the chat if you listen to me. I'm live right now. Thanks. I'm waiting for the rest to join the stream. 6 are right now watching. Everyone, can you listen to me? Please type something on the chat if you listen to me. I'm live right now. Thanks. I'm waiting for the rest to join the stream. 6 are right now watching. There is a little bit lag, but that's fine. Can you listen to me? Type something on the chat if you listen to me. I'm live right now. Thanks. I'm waiting for the rest to join the stream. 6 are right now watching. There is a little bit lag, but that's fine. Can you listen to me? Let's the number reach to 12 or 15, then I will start the stream. I'm waiting for the rest to join. I believe we are about 20. I'm waiting for the rest to join the stream. Right now watching. Let me check here. There is a little bit lag, but that's fine. Let's the number reach to 12 or 15, then I will start the stream. I'm waiting for the rest to join. I believe we are about 20. Waiting for the rest to join the stream. Now watching. Check here. A little bit lag, but that's fine. Let's the number reach to 12 or 15, then I will start the stream. I'm waiting for the rest to join. I believe we are about 20. But that's fine. Okay, I'm starting the chart right now. So I believe I sent you the data and I send you the software tool, the software we'll be using for this workshop. Yeah, that's fine. We have 15 right now watching me. So I sent you this outline. This outline describes what we will be learning today or what we'll be doing today during the workshop. So basically I sent you the data. I sent you also the software. By the end of each session, today is the first session, tomorrow we'll be having another session. and next week we have 2 sessions. The total number of sessions are 6. So the length of the workshop is 6 weeks. Oh, sorry, 6 sessions, but 3 weeks. And by the end of each session, I send you a small quiz. So the one who passes all these quizzes or get good marks in all of these quizzes, he and or she will get a certificate of participation in this workshop. So it's very important you listen to me, you watch all the videos, you do the quiz and send the results to me. So for today, I believe everyone already received the data and the software. Uh, if you have any question, please write down in the chat. If you have any question, please write it in the chat so everyone listens to what I'm saying. So what about the data? Have you received the data? The data are quite large. It's about 700 megabytes. The software size is 200 or 300, I don't remember. But I sent you the instructions how to install the software. For today, I will try to use the software, create some jobs. You follow with me and write down either in here or in the group we have in Telegram. So write down any notice you have or questions you have and raise your hands whenever there is anything unclear. So basically the software name is Claritas. It's a very famous software, and the way you launch it is just double click and wait for a while. That's the screen you're supposed to get. That's called also launcher. But first of all, let's talk about the data. In here, I'm saying what you're gonna learn, and in the next slide, this is what I explained earlier, that there is a practical and there is also quizzes you have to do. Apart from that, the data itself is 2D data, it's simple data, it's marine data. It's not belonging to Oman, it's from New Zealand. The good thing, they are free, anyone can access them. It's a 2D line. The length of the line is 22 kilometers, and the direction of the shooting is 90 degrees. The total number of shot points or shots made along this line are 875. So I sent you already the data. I hope that everyone got the data. The parameters of the data are as follows. So let me draw these things on the board so you understand what I mean by these parameters. So the first thing, as you see, there is an air gun, that's the shot. So let's assume that this is the marine, that's the seawater or water table. And those are the layers underground. So in 1D layer case, there is a boat and there is a gun. They call it air gun. It's a source which sends energy to the ground. And there is a stream as well. So the stream is made up of geophones. This is one group of geophones. This is another group of geophones. And there is a spacing between them. So this is the spacing. And behind that, there is a tow buoy. The purpose of the tow buoy is to make the stream along specific depth of the sea. So this is the source I have. It's called air gun. And the depth of the air gun is 6 meters. That's 6 meters. And the shot interval is 25 meters. It means that every time I move 25 meters, I make a shot. And that's the stream cable. That's what you see on the screen. And the number of groups, the number of these groups are 25. That's 1 up to 120 or 25. Sorry, 125, 120. And the depth of the streamer is 13 meters. That's 13 meters. And the near offset is 258. That's the near offset. This is the offset from source to the first group. That's 258. And this is the far offset. The last, whatever the last one is, that's the far offset. Far offset is 3,233 meters. And the sample interval, we'll talk about the sample interval and the record length. We'll see these details later on, but this is the configuration, basic configuration of the shot gather. So again, this is a real picture. What is a short source gun? And usually they are deployed in terms of array. It's not a single one, it's an array. So in this case, as you see, there are 3 air guns. They can be fired simultaneously or one after another within a specific time interval. Here is the configuration we have for 1D, that's 1D, and this is a 3D. But the data we have is 1D. So this is in this case, what is the near offset is 20 meter, and the far offset is the distance from the air gun to the last group. Sampling interval, as you know, the data are acquired in analog forms. We convert them to digital forms. And the digital form is digitization of the data. And it's a concept in geophysics. You don't need to go into detail too much right now, but it depends on how much information you need into your data. It also determines the size of your data. If you want your data to be large in size, let me make some modification in here so you can see me as well. Sorry, I made a mistake in here. You can't see me right now. Can you see me right now and see the slides too? Yep. So back again to the slides. So for today, we'll use the software called Globe Claritas, and we'll learn how to use the help within the software, and we'll create some jobs. I teach you how to create the jobs. For today, we'll use only 2 jobs or create 2 jobs together, but I believe the total number of jobs might be up to like 50, from 40 to 50. So within these 6 sessions, we'll create up to 50 sessions, 50 jobs. And I will let you know what is the purpose of each job and how we create the jobs. So the first time you launch the Claritas, you're supposed to get something like that. That's called the launcher. If you don't have it right now, you're just watching me, it's fine. But the details are all written in the slides. If you go along the details, you can follow again what I'm doing right now. So that's basically the launcher. And if you go to the help, all help, it details all the workflows or the modules available within this software. So back to the slides. First thing we need to do is to create a project. How I can create a project? The project can be created basically by going to the project and clicking on create. The project ID, you can name it whatever you want. For example, let them name it TRV434. That's the line number. TRV Taranaki Basin. The data is from Taranaki Basin in New Zealand. And the line number, the 2D line number is 343. And you specify a directory where to save your project. So by default, it will be saved in Hay. That's fine. And the rest are just optional. The red one are the mandatory fields. Those are the one you need to fill. Without them, you cannot create the project. Once you are done, you can click OK, and you're supposed to get the status of OK. It means that the project is created. So following along the line, that's what I explained. Whenever we go to some job, I will try to explain what are the help available within each specific like module or each job itself. But the like what I name them, the assignments I give you or the quizzes you do, you need to get some help yourself. So what is SIGY? The data I gave you. The data I gave you, it's in SIGY formats. That's the name of the data, original data. How you can open it? I send you a software called SizeC. That's the software. It's optional software. You can use it if you like. But the good thing about it, it can open any SIGY format. SIGY is a standard format of seismic data distribution. It's standardized by SIGY or SEG. So let me open my data. I think they are in desktop. They're not in here. Let me check again. Oh, no. They're an external drive. SIGY. So here are my data if I normalize them. So this is the data. You see, this is one shot. These are the traces. So each line in here is basically a trace. And these are the basic information we need to know about the seismic data or SIGY data. So first of all, there is these headers. We have text header and we have trace header. We have the actual data. Those are the actual data. So if I go back to my SIGY, so this is, for example, binary header. This is the binary header, which is this one. And I also have, for example, trace header and text header. This is the text header, which is basically this part or this one. 3200 bytes. This is the text header. The data themselves, the data themselves, you can see them in, let's see back in here. These are the data. So this is in here the data, trace header data. But apart from that, I will show you how you can see them in Claritas software itself. So how I can read the data? I basically go to the launcher again, and I go to seismic data. I go to seismic data, seismic view, input seismic, and get my data. The data is SIG-Y, so here I select it, or better use analyzer. Let's use analyzer instead of analyzer, because we don't need to output the data. So here is again the same information as before. If I go back to my slide, so the first that I see is this one, this part of the SIG-Y, which is basically here. It's all a text. It's describing where the, for example, the data acquired and who acquired it, belongs to who, and similar information. Apart from that, let me check if everything is fine. So this is 400 byte. These are very important information. They include information like what is sample interval and what is the format of the data. So they can be found in here. The rest, this one, 3200, they are within traces. So these traces, they are the data. So how many traces are there? There are 120 traces. If I go one by one, the last trace is supposed to be 120 traces. That's what I have explained earlier in the whiteboard. So I have 120 channels or traces. Channels are or traces, they are the same. Usually they can be within a group, so there are more than one hydrophone in terms of marine data. The data are acquired by hydrophone. So one channel is representing many geophones or many hydrophones. So if I scroll through them, the last number I'm supposed to get is 120. I can view them. So this is basically one trace. I can go to the next one. The error I'm getting in here because the headers, trace headers are not set properly. This is one of the tasks we're going to be doing in some of the coming sessions. So these are each traces. So you can scroll through them. These are not shots. So shot itself is starting, if I go back to the first one, or simply just close it and run it again. So this is one shot. So this is the far end, this is near end. This is the near end and that's the far end. For the time being, let's close this one. Let's close this one. So I believe you get an idea what is exactly SIG-Y. SIG-Y is made up of different headers. They are like text headers explaining what the SIG-Y is, where it's acquired, who acquired it, and information like this. There is another header, trace headers or binary headers. The binary headers, they include information like what is trace sampling. Trace sampling for SIG-Y is supposed to be one number. You cannot have different trace spacing for each
trace. So all the traces supposed to have one single trace value. Other than that, we have like trace header. Trace headers include information like what is the XY location of each trace, and what is like elevation of each trace, the GFON elevation when the data acquired. They are included within this part. This is the nth, for example, first to nth trace header, and they include the data. The data they come from our case. We have how many data? We have 120 channels, and there is a data in each 2 milliseconds. That's the sampling interval in our case. So each 2 milliseconds there is a sample data within a simple trace. So if you want to calculate the total number of data, what you're supposed to do, you're supposed to get the total number of channels, which is in our case is 120. You're supposed to know as well what is the total length of each channel. In our case, it's 600. And the sampling interval. Sampling interval is 2 milliseconds, but it have been resampled to 4 milliseconds. So we'll let you know why we have resampled the data. The data, what happens if I resample the data from 2 milliseconds to 4 milliseconds? The basic thing happens to the data is the size of the data. The size of the data gonna decrease if we increase sampling interval. But sampling interval is usually determined during the acquisition phase. When they acquire the data in the field, the sampling interval is determined there. But we can resample them. Usually the resampling is made by increasing sampling interval. Instead of like having 1 millisecond, we make it 2 milliseconds or 4 milliseconds. These are the common sampling interval we have usually with seismic data: 1 millisecond, 2 milliseconds, or 4 milliseconds. So the first thing, I think I already covered this part. It's how to read the data. You go to SIGWAI Analyzer. It's basically from here, Seismic Data Analyzer. It's like similar to the other software we have seen, SeisC, but I think this is more nicer. You can view the data in much cleaner way using the Seismic Analyzer available within Claritas. So how we can create jobs, and what exactly is a job in seismic data processing? A job is a sequence of instructions you apply to the seismic data to enhance them, to filter them, to make different thing in the view. You can even, for example, get the input data and write it in a different format. All this sequence is called a job in seismic data processing. Remember, we have 2 hours, and at the end of the session there is a short quiz. The quiz is going to be sent to you by the group chat, and you can attempt it before the end of this week, or by the end. Let's make it a bit longer. So at the end of this week you have the time to attempt the quiz. You can help each other. It's open quiz, but the idea is you need to do the quiz and send it to me. So the initial thing we need before doing anything to data is to view the data, to QC the data, to see what's available within the data. What are the type of noise? In seismic data, the noise is meant by anything which is undesired. Anything I don't like to be part of the seismic data, I call it a noise. A noise can be, for example, in simple seismic data, is someone moving while I'm acquiring the data. In land seismic survey, I want that there is no movement except the source, the energy source I send to the ground. So my geophones or the hydrophones, they listen only to the source I send not external sources created by human or any other thing. Wind can be like a noise in land data. The marine data, they have their own noise types. One of the noise types in marine is swell. We will see that and we'll learn how we can remove it. So we'll talk first about an application. The application called is XSGE. Let me say something. Don't be afraid because the terms might be advanced to you. The idea is to learn something. If you are like a student, you haven't taken seismic data processing course, that's a good opportunity to learn something. If you are already graduated, you expand your knowledge. If you already have taken the seismic data processing or you are taking it right now, regard this workshop as an extra assignment or extra thing you learn. But whatever you are doing with your own course, like seismic data processing course, is quite, I believe, is similar what we're going to be doing in here. So how I can launch this application, what's called KSGE. If I go back to my launcher, there is something called flows. That's the flows. If I go to job files, here is a job. You can list available jobs. Right now I don't have any jobs. So this is the project I created. The name of the project is TRV343. You remember? That's the project I created. I named it TRV343. Whenever I'm searching for something, check what is the extension you have. For example, for job files, the extension is .job. So let me check what I'm receiving in here. Okay. By default, the job's supposed to be saved in this directory. If you go back to the project, that's the project, then common, and the job's supposed to be saved in jobs. But for some reason, I'm not sure why, they are saved in the home directory. That's the home directory. Whenever I select, this is my home directory. This is my user group within the home directory. Where is this home directory? Where I can find it? If you go to your C drive, if you follow the instructions I send you how to install the software, you go to C drive, go here. This is where you save the software, and that's the home drive. So this is my project. Here I have my project. And the common directory and in the job's supposed to be saved in here, but it's fine. Wherever they are saved, it's fine. You can save if you like. I recommend saving them to jobs. So if you go to job, for the first job we create is QC. Let me double check what the name is. Yeah, that's QC00. Why I name them by this? Because I want them to be sorted. When I view them in my Explorer, like File Explorer, the numbering will help me. So will not go beyond 100. 00, so the maximum number is possible in this case to be sorted properly is 2 zeros or double zeros. The first job is 00, the second job is 01, and so on up until 99. But you're not gonna have more than 99. The maximum probably we have is around 35 to 50 or 40 to 50. Let's see how it goes. So let me copy this one, bring it back to my software, and I name it this. If it's not available, if there is no already made jobs, whatever name you give, this will be created as a new job. If I say open, so it gives you the option. Do you want to create it? Say yes. So it's gonna be saved in the directory I wish it to be there. In this case is job directory. I click OK. So the first thing you see a module. This is a module. This is your job sequence. Whatever you brings of modules and you click run, the processes you bring in here, they're gonna be executed one by one. This is the first one. The first one is size job. It's a simple name. You don't need to change it. If you like, you keep it as it is. But later on, later in future jobs, we'll do some change to the first module, which comes by default. Then what we need to do, we need to bring some other modules. So the next module, by the way, everything is explained in here. This is the slides I sent to you. So if you follow them, let me maximize it. If you follow this one, you can do whatever I'm doing right now yourself. I give you up to the weekend, end of this weekend, to do this yourself, and I send you for probably today the quiz. You try to attempt the quiz and send me the results. So in this case, in this job, these are the modules I would like to bring. The next module, 0.2, is disk read. Disk read is the data, the name suggests, reading the data. This reading a disk. The seismic data in old days, they are saved in disk, normal disks. Nowadays they are saving them in USBs or other flash drives. But in old days they were named in disks. The name is just conveying the normal old convention, disk read. So in disk read, what I gonna do, for example, in this module, this is the parameters I have to set. So if I go back to my package, from where I can bring data, you go to add, not data, modules. You go click on add, and as the name suggests, read or disk read, something similar to read supposed to be in input. So if I go to input, I will find that's disk read. And what's the description of this module is reading SIGY or Claritas disk files. I double click on it. If you don't want to double, let me cancel it. Input output, disk read, okay. So you get something like a pen. You put the pen wherever you want in the sequence, and it will be inserted there. So that's, in this case, it's inserted basically below the size job. And what the parameters I set in here is similar to what I see in my slides. For this case, for example, what is the disk file? Disk file is the file I sent to you. So in this case, I have it in my flash drive. I go workshop and SIGY, this is the file which is almost like 650 mg. And here I don't read all the data, so I read part of them. I'm doing 200 to 900 over 100. What does that mean? I read from shots or primary key, which is the shot in here. How many shots I have? I have the shots from 100, 1 up to 955 or 50 probably, or 9. So that's the shot numbering. Those are in trace headers. So do you remember when I talked about the trace headers? One of the trace headers is shot ID, and the other trace header is channel. So in this case, the secondary key is channel. How many channels I have? Is 120. So good thing that the software recognizes these things. So it recognizes also what is the total length, trace length, TR length, that's the total trace length. So starting from 0 up to 6,148 millisecond. That's millisecond. The data, seismic data, they are in time, if you are not aware. or the seismic data, usually they are in time. We are starting from 0. There is no time below 0. As I said, the data were resampled. Why they are resampled? To decrease their size. And whenever you see that there is no differences between 2 milliseconds to 4 milliseconds, and there is no aliasing, something called aliasing. I don't need to go to what's exactly aliasing. You just remember that the data were resampled to 4 milliseconds from 2 milliseconds. So this is the sampling interval. The rest of the parameters, they are optional. These are the things you need to read. So what is this? What is the primary key list? I read from 200 to 900. I don't read all the data, part of them. And I read every 100. So the first shot is 200, the second shot is 300, 400, up to 900. The total number of shots I'm going to be reading for this case is 8. So I read 8 shots from 200 to 900, including them. So that's the reason they are 8. So the total number of shots is big, is from 100, I believe, to 900. I need to revisit the trace headers to know what exactly the number of shots. So they make, what is exactly a shot is you fire up your air gun and let all the channels, all the group of GeoPhones, they read the data. So I get one shot gather. I get one data representing a shot gather. The data, they are still in shot gather domain. We'll talk about the data domains later on. There is CDP domain, there is stack. So we'll talk about those terms later on. But remember that a shot or shot gather is basically whenever you fire a shot and all the channels are active. In this case, there are 120, they are all active. By active, I mean they're all reading data. So I get a shot gather. I click OK. In this case, then the next step, if I go back to my slides, the next step is coordinate. Coordinate scale is, do you remember the error message we were seeing? The coordinate scale is not defined. This is not the correct coordinate scale. Like the shot interval, the coordinate in terms of coordinate scale, I say what is the interval between each specific trace, and what is the interval between the shot to the first GeoPhone, the first channel, the interval or spacing from the shot location to the first GeoPhone in 1D. That's my shot. This is my first GeoPhone. What is this spacing? They are not defined in my SIGWI file. They are not available in the trace headers. We need to apply them or provide them to the SIGWI later on. This is going to be one job we'll create. So sometimes you know the data yourself, but they are the parameters of the data, but the specification, they are not set in the SIGWI. You need to review the SIGWI or the data you receive and import or fit this information to the SIGWI. So the next one is coordinate. Coordinate is supposed to be in trace headers. Yes. See, set headers. Set headers. That's the one. I put it here. And chord scale. I type it. That's the trace header. I name it 1. That's a value of the trace headers. So you say probably how we know these names. They are usually different from one software to another software. That's hard to tell. But each software there is in the help, if you go and list all the trace headers, chord underscore scale is one of the headers. The other headers like group interval and the location of each GeoPhone while the data were shot. They are all supposed to be available in the trace headers of the SIGWI file, but in some cases they are not available. but you know them beforehand. Then you need to input them or set them into your trace headers. I'm satisfied. I'm just clicking OK. That's exactly the same what's outlined here in my slides. Then I need to bring something called XView. XView is a parameter or a module which let you view the data. So it's supposed to be in plotting, probably. XView, yes. You see by the name, the description, interactive seismic data display. And I set it here. So I set the parameters similar to what I see in my slides. So it's not a single channel. It's a fixed length of channels. I display a fixed length of channel. What is the fixed 120? And what is the number of gathers? What is the number of shot gathers? It's 8, as I said before. The rest you can keep it as it is. There is no changes. So if I click OK, that's almost ready. If you check what I was having in here, that's exactly what I did. So this is my job. This is a ready job. I can run the job by just clicking in here. If I run it, so the task is built, is complete. Here is my data. So here is my data. So you see this is basically the first shot, number 100 or 200. The next one is 300, and those are the trace or channels. This is the primary key, shot ID. That's a trace header. The secondary key in this case is channel. The channel is ranging from 1 up to 120. So this is one shot. So how it works? The ship in the marine, the vessel or vessel dynamic, the acquisition vessel, it fires a shot, record the data, and moves 25 meters was the shot interval, I believe. I forgot, but it's in the parameters. It's also in the parameters of in the slides I showed you earlier. So it fires and moves. Each time it moves by specific interval, it fires again. So this is one shot gather. This is another shot gather. The total number of shot gathers in this case, if I move, it's 8. So the last one is 900. Why I'm having 8 only? Because do you remember when I read the data, I specified what is the total number of shot I need to read in this case. I'm not doing any filtering. I'm not changing the data. I'm just reading them and viewing them. So let's see what is the maximum length. That's exactly what was written in the parameters. 6148 probably. Yeah. Another nice thing in here is the view you can. For this case, this is, for example, variable density. This is variable areal wiggle. This is variable areal. What I mean by variable area, this looks like a wiggle. It's a wiggle, one trace, but one part of the wiggle is colored or filled with a blue color. This is similar to this one, but here it's not colored. There is no filling. So these are the type of displays we usually use for seismic data viewing. This is one of them, and the variable density. Another thing, if you go to colors, for example, here, these are the different colors you can use. So right now I'm using grayscale. If this can be applied only for variable density. If I go back to variable density, This is variable. What I'm saying right now, they are explained in the slides. So if I go back to the variable density, this is the color scale I'm using. So this is the color scale, starting from value of, what is the value, 17. Here is, so if I put my mouse here, I read the value in the cell 17, and the last one in the line is 32. So this is the grayscale. Let me see another color scale. Let me see, for example, this is very famous color scale as well, blue, white, red. So this is blue, white, red. So the first cell is reading 65. Let's see what is the last one. The last one is 80. How I can apply this thing? How I can apply? It's not very simple, intuitive. You go to parameter, you go to parameter, keep clicking it, double click and keep clicking it. These are some basic testing you can do. You can apply like FK spectrum or whatever. They are simple testing, autocorrelation, amplitude decay curves. We'll go through these, not all of them, but majority of them. We'll go through all these. These are the testing you do usually to check what is the best parameter you probably need to use for whatever filtering you're doing. So main plot, for the first case, main plot allows you to change the color scale. For this case, for example, 17 to 32 was gray color. How I can bring it to the other color scale, blue, white, red? It was from 65 to 80, I believe. Am I right? So if I apply, that's my color scale. Another thing, you are not seeing the data, all the data. How I can change the vertical scale? So this is the vertical scale. Let's make it, instead of make it 3, for example, so I can see everything. Oh, not 2. So here I'm seeing all the section from 0 up to 6,000. Another thing, my range is too big, so I'm not seeing everything. The range I'm seeing, I'm using right now is from minus 250 to plus 250. So here the blue one is minus 250 and the red one is 250. So this is the color scale. How it is defined? There are some data, especially you see this one, they are very large values. Why they are very large? This is seabed reflection. What is seabed? That's the seabed. That's the first reflection you receive. The data, the source energy goes down in the sea column or water column, hits the ground, hits the seabed, and reflected back. That's the strongest reflection. So it gives you very strong value. There are some values within this range. We later on remove some of them. So we try to remove them and balance our data. So if I go back to main plot, here I can change the scale from minus 250 to plus 250 to lower value. Let's make it, for example, let's make it 0.5 to 0.5. Let's try to see how it looks like. Yep, that's better. So this is my data. So what type of noises you see? This is a noise. This is a noise. These are some noises. There are some noises in here too. This, the upper part is noise. You see this trend in here? There is a trend like moving in this direction. I'm seeing it always also in here. Those are noises. So we'll try to detect first these noises and remove them. So the first job was simply this. This is the first job. The job name was QC, or quality control. We try to view the data, see how they look like, and change the viewing parameters. You see this in here, this is also a noise. I'm seeing this pattern in here, this is a noise. What I'm after in this case, I'm after those. These are the data I need. Those are the hyperbolas or reflection hyperbolas. You see them making like shapes of hyperbolas. I try to boost these data or the signal. The signal in this case is the reflection. I try to boost them and eliminate whatever noise I'm having. So this is a noise. In here I'm having a noise. They are almost covering all or hiding all the signal I'm having. The seismic data processing, or the purpose of seismic data processing, is to remove the noise, enhance the signal, and produce a section of the seismic data which is closely resembles the true Earth model. That's the main purpose of seismic data processing. So you can close it. If you are happy with your data, you can close it. How I can, for example, define these parameters, whatever I change. So every time I click the same job, I run the same job, I exactly get the same display. They can be done from within. So this is a log file. Whenever you get an error, it says what was the error exactly. If there is something wrong in your process, it's supposed to be displayed in here. It says what exactly went wrong. For this case, job completely successful. So job completely successful. So there is no error. And it's saying how many traces I'm reading. From 0 to traces out, how many I read and how many output. So everything is fine. So I believe total number of traces is 960. Yeah, I think so. So because we have 8 shots. 8 shots. In each shot is 120. 120 times 8. Probably I get 960. Yeah. So that's what I read. You need to view these parameters sometimes to make sure that everything is fine. In terms of time, some processes, if you are using your laptop and your laptop is not quite strong, they might take some time to finish. So for example, for this simple job, which is just viewing some data, it took like almost 500 or 600 seconds. It's not big time, but that seismic data processing usually is very computer intensive. It needs a lot of computer power. Here is my laptop. If you computer, this is way more strong. But the problem I'm having in here is I wasn't able to manage to stream from here. I couldn't buy a webcam. All the shops nowadays are closed, so I couldn't get a webcam to use for my streaming from here. But hopefully the next days and the coming sessions, I try to get a webcam instead of webcam and stream from here, from my main PC, instead of streaming from my laptop. So what is left? This is almost as the first job. We are done. We reached this point. We view our data. This screenshot, by the way, was taken from my main PC, so that's the reason I'm seeing more data. So these are all the explanation what exactly I'm doing. Again, I forgot something. So how I can actually save the parameters. So every time I click run, I get exactly the view what I have changed in the parameters in main plot. So let me close this one. Go back to my so I go here. You see this in here. You can change these parameters in here. Let's put 0 point minus 0 point. Sorry. Minus 0.5. 2.5, I think it was 65 to 80. So this is one of the parameters. Horizontal scale, vertical scale, how much we put it? 2, I believe. So these are some of the parameters you can change in here before running the job. So let me run it again. What? Was it saved? Let me double check very quick. Yeah, not sure. Anyway, maybe I need to change the palette too. Yeah. Anyway, if it's something is wrong with it, we better skip it for the time being. Interesting. I did the same jobs in here in my PC. It was running fine. Anyway, so whatever right now in the slides, this slide exactly, slide number 20 out of 30, explaining all the details we explained earlier. So automatic gain control. We need to bring right now automatic gain control. Automatic gain control is type of filter which boosts the data. Does not boost the signal only, boost all the data. It destroys the amplitude as well. The amplitude information, they are destroyed too if we use AGC, automatic gain control. But we try to apply it, use it in this case, and see what it affects, how it affects our data. So let's try to use AGC. From where I can get AGC, I go to add, on the filtering trace scaling, AGC. I bring it before the view, so it's supposed to follow this sequence. So in AGC, the details are all written in here, what exactly AGC is doing. So the details are written in here, what exactly AGC is doing to the data. But there is a window in this case. And what about the desired output? Because if I go back to my slides, I see some parameters. I see desired output. And this is the window, T is the window length. So in this case is 500 milliseconds. So this function is applied on all the first 500 milliseconds. Then we move to the next 500 milliseconds. We apply the same function. That's the function. The desired RMS in this case is 1. You can change only the window length. So the higher the window length you make, the least like boosting you are doing to the data. But you are least affecting the data. The smaller you make it, the higher the boosting you are doing to the data. But the wrong thing is that you cannot distinguish between different data types. They will look all similar. All the data amplitudes within the data, they look very similar. Let's try the default one, 500. Let's go back to my job. This is AGC. If I run it right now, you see all things are boosted. They are enhanced. But I'm enhancing also the noise. So in here, this is all noise. The noise are enhanced. So you might say, what is then the purpose of the AGC? AGC purpose is only viewing the data. You want to see all the data. So there were, like before, there were no data I was seeing here in the lower section. But everything is posted right now. If I make it different, for example, make it, let's say, 1000 instead of 500, the total length is 6148. So this is 1000. Stay lower than the total length. You cannot make it larger than the total length of the trace or trace length. If I apply it again, so least noises or the data are not boosted equally in everywhere. Try like 1000, see what happens. 2000, see what happens. Try half of the length, like 3000, almost half of the total length of the traces, and see how it looks like. If you make it 1000, nothing changes. Oh, sorry, no one, 6000. If you make it 6000, nothing changes because that's exactly the same as the trace length. So that's the first job. This is a job. This job is not doing any filtering and I'm not changing anything in the data. If by any case, if you want to disable any module, you just go commit it. So it's not gonna be run. It's not gonna be executed while you run your job. And you can disable anyone and again enable it again. You can copy or select one of them and paste it in another place. Usually we do the same, like the same filter twice or 3 times. It happens quite often. But in this case, if you are happy with your parameter, if you are happy with what you have done, you just click in here, save and exit. Choose the first one, save and exit. Save as, you will save it as a new name, but we want to save it as the name we already selected. So save and exit. I go back to the launcher. So these are the jobs. If I go select list, see my jobs, common jobs, this is the job I just created. So the task for today, the task is to complete the rest. There is one more job you need to do, and send me this data. Send me similar what you see in here. This is your task or uh, what you're supposed to do. And I send you also the quiz either today or tomorrow. Let's see if we can manage to make the session tomorrow. I will be in contact with you all in the group chat. See how it goes. Hope everyone learned something, and if you have any questions, I'm right now opening the chat. You can ask me any questions you like. If you don't have questions right now, you can ask me later on in the group chat. Oh. Yes, Zolfa, it's gonna be saved. So I'm quitting right now, and we'll see you next time.